today. Jokes aside, on behalf of my friends, I will introduce you to RISC and CISC. Instruction set architecture is also known as CPU architecture. ISA allows communication between software and hardware. It is also a group of commands for CPU and machine language. Basically, ISA tells you how your processor is going to process your program's instruction. Instruction is also aka opcode or operation code. The examples of opcode are add, jump, load, and store. There are two types of ISA. The first one is CISC. CISC stands for Complex Instruction Set Computing. It is an architecture with large number of instruction sets. For instance, the microprocessor of CISC is Intel 64, which is the 64-bit version of 86 instruction set. They are mostly found in desktop and laptops. On the other hand, RISC with a C is another type of ISA, which stands for Reduced Instruction Set Computing. It has lesser set of instructions. For example, ARM processors are extensively used in consumer electronic devices such as tablets, smartphones, and even gaming consoles. To understand these two components, let us take an example of multiplying two variables, A times B. For the CISC, they have a specific instruction called mult, also known as complex instruction. Thus, the entire task of multiplying two numbers can be completed with one instruction. Well, for the RISC, the mult command is divided into three separated commands. Now we will move on to the differences. The major difference that most people never notice is that CISC starts with a C and RISC obviously starts with an R. Just kidding. Teehee! Alright, now let's watch a battle between RISC and CISC. Sorry for that. We will continue the boring old way. The first difference is CISC has more instruction sets than RISC. The instruction cycle in CISC is more complex than RISC, whereas RISC must combine simple operations from their reduced instruction set. CISC is mostly emphasized on hardware, while RISC is mainly in software. The execution time for CISC has multiple number of cycles per instruction because the instruction sizes are smaller. For RISC, it is one cycle per instruction because the instruction size is larger. Take from the previous example, mult itself is a command in CISC while RISC has three separated commands to do multiplication. The other difference is that CISC CPUs are much larger than RISC. This is because they have a larger instruction libraries and a fan installed to cool it down. Otherwise, it will blow up in your face. Literally. Due to the reduced instruction set, RISC CPU can be put onto a single chip. This makes them very light and allows it to make portable devices. Since CISC CPUs in size are bigger, they would of course use more electricity. RISC has lower energy requirements and can go into sleep mode when not in active use. Finally, the last differences is the speed. CISC CPUs takes a little while to process the instruction, whereas RISC CPUs will
just do it!
But wait, there's more! RISC can only perform simple tasks quicker than CISC, but CISC are more capable in handling intensive tasks, which makes it better for a larger variety of tasks.
And the winner is... His name is John C. Why?
That's because both are suitable at its specific applications. In today's evolution, we use both RISC and CISC technology, which we call EPIC. This will be covered in another episode. Thanks for watching!